Hello, welcome to this massive online open courses on digital image processing. In this course, we will talk about the applications of digital images in various domains. As you know that when you talk about digital image or a picture, normally we consider that to be for entertainment purpose. I mean, whenever we have a picture or an image, typically we think of that we have gone somewhere, taken some snaps which are for references later on. But in addition to that, digital images has many more applications. Say for example, today if you visit any railway station or you visit any airport or any area which is under surveillance, you will find that there are a lot of digital cameras which are tracking your movement, and these are nothing but tracking through images, and these images are actually monitored in a control room. So, that is one of the applications where imaging or video photography is used for the surveillance purpose. Similarly, images or digital images have wide application in medical domain. You have seen X-ray images, tomographic images, ultrasonic images, and all different sorts of images which are used for diagnosing any particular disease. Digital images are also used in heritage preservation. There are images which are three-dimensional images. Digital images are also used for visualization of any physical event. So, you find that the application of the digital image processing is widespread. However, it is also true that for different types of imaging applications, the imaging modality or the way the images are created, that will also be different. But finally, whatever be your digital image acquisition technique, once the image is acquired, it is nothing but a two-dimensional array or a matrix of integer numbers, where every element in the matrix, which is nothing but an integer, represents certain quantities in that two-dimensional array. So, when we talk about the normal optical images, this quantity in the two-dimensional matrix represents either the intensity, that is the amount of light which is reflected from a particular point on the imaged surface. It may also represent the color, having three different components, usually red, green and blue. It may be the depth of the object from the camera, which we also called three-dimensional image, or normally 2.5 dimensional image, because we get only the surface information. When we talk about the medical images, we have MRI, we have CT scan, all these different sorts of images, where the imaging technique is either using the magnetic property, or the imaging technique is based on the absorption of say X-ray energy when an X-ray ray passes through an organ or through a body. But once I get an image, this image, as I said, is nothing but a two-dimensional matrix, where every element in the matrix is an integer number. So, there are many common problems in all these images, whatever be the imaging modality. One of the common problem that we have is the presence of noise. The other common problem that we have is the image enhancement, or the images that we get that may not be of sufficient quality for a particular type of application. So, in this image processing course, we will talk about all these different types of techniques, or we will talk about different types of mathematical techniques, which will be useful for removal of noise or enhancement of an image, so that image can convey more information either in the form of visualization, or it may give you more information, the information which is required for a particular application. Now, when I say that in the form of particular application, typically what I have in mind is the machine vision applications. So, when you go for machine vision applications, we assume that there are some machines or a computer attached to something else, say for example, with a robot. So, the images which are captured using a digital camera, that will go to a computer and the computer will process it. After processing, the computer has to identify maybe the objects which are present in the image. So, when it is identification of an object or identification of something which is present in the image, simply enhancement or removal of noise is not sufficient. What we need to do is, we need to enhance the images so that the object identification becomes more convenient. So, the kind of application for this type of enhancement, and when you go for noise removal, that is also a sort of enhancement, but which is mostly for visualization purpose. So, these two enhancement techniques or the aim of these two enhancements are not same. So, when you talk about an enhancement of an image, the enhancement is application dependent. So, we will talk about the various enhancement techniques in this particular course, and all these techniques can be applied either on the raw image itself, or you transform the image to convert to say transform coefficients, or in other words we say that we represent the image in frequency domain. So, we can have operations both on the raw image, which we call as spatial domain processing, or we can have equivalent operation in the frequency domain representation of an image, which we call frequency domain processing. So, we will also talk about what are the different transformations which are applicable for images, so that we can convert a raw image or a spatial image into its corresponding frequency coefficients, and how a particular technique which is applicable in say raw image or in spatial domain, how we can have its corresponding technique or equivalent technique in the frequency domain. So, we will talk about this conversion from the spatial domain to frequency domain. We will also talk about the corresponding techniques. Now, when I go for machine vision application again, as I said that their aim is to identify certain objects and recognize certain objects. So, before doing that, what we need is, we have to identify the region of the image or the points in the image which corresponds to particular object. So, we will see that an image will contain two different types of regions. One of the regions we will call as foreground region, the other region we will call as the background region. So, it is the foreground region pixels or points which are of interest for machine vision applications. So, this is a technique which will be done through a process called segmentation. So, given an image, we want to segment out the object, and once the object is segmented out, then we want to recognize or we want to understand what that object is. So, this is a task of a level of image processing which is called higher level image processing technique or computer vision technique. So, to identify or to recognize an object, what we need to do is, once the object is segmented out, we have to get a description of that particular object. So, these descriptions can be of different forms. The description can be the shape of an object. So, if I have a football, normally the shape of a football will be a circle, whereas if I have a building which is captured through say a satellite image, the shape of the building will be either rectangular or square or things like that. So, these are what we mean by shapes. So, when you get descriptors of an object, these descriptors, one of the type of descriptors is the shape based descriptor. The other kind of descriptor can be region based descriptor. That means, given an object, what is the property of the area which is occupied by that object in the image. So, this can be color information, this can be texture information, this can be intensity information. So, I can have the corresponding descriptors of the color, intensity or say texture, which are known as region descriptors. So, any object will have two types of descriptors, one is shape descriptor, other one is region descriptor. Then we will talk about that once I extract these descriptors, we will also discuss about how to extract these descriptors, and once you get these descriptors, then using these descriptors, how we can go for recognition, or how we can say that an object is of a known object of type A, or it is an object of type B which are known. So, these are the high level image processing techniques or the recognition techniques, or typically known as vision techniques, computer vision techniques. So, in this particular course, we will start with the imaging process. We will talk about how a camera or digital camera creates an image of a particular scene, what is the mathematics involved in it, what is the camera model which can be used so that we can, given a scene, we can get a two-dimensional image. Once we have a two-dimensional image, then what are the different processing that we can do on that two-dimensional image, so that the processed image is more suitable for certain kind of applications. These applications can be either visualization, or these applications can be applications for certain specific problems. So, this entire course contains 40 hours of lecture, which is broken into different modules, and the course will be running over 14 weeks. So, given this small introduction of the course, I welcome you to this course on digital image processing, which will be on massive online open courses mode. Thank you very much.